that we got to give dividing a look. So dividing, and we'll start out, simplify, and here we have 42 over 63. We want to simplify this down. Something that's from your basic math class. Maybe you did this in 3rd grade or something like that, just simplifying a fraction. And I just simplify this by 3. So I know that this is going to be 21. And we do this by 3, we get 14. And then I know that 14 and 21, I can reduce it by 7. And what do we get? We get 2 over 3. Okay? Simple couple ways to reduce it. I always just start picking out numbers. Pretty straightforward. It's not what we're doing, but it's a good example of how we're going to start taking 2 fractions and reducing them. Those are whole numbers. What if we have this? X to the 3rd over x squared. What am I going to do there? We have x to the 3rd over x squared. If we write this out, we're going to say this is x times x times x over x times x. What happens? We go bam, bam, leaving us with x. So our answer is x to the 1, or just x. Okay? Not too bad, but then you say to yourself, well, what if I have something big? What if I have x to the 7th over x to the 3rd? Do I have to go x times x times x times x? 7 over x times x times x. Do I have to do this every single time? Because it does give us the answer, right? And leaving us with x4 or x to the 4th. Okay? And hopefully you see it by now what's going on here. What's going on? What is the rule? How am I going to do monomials? How am I going to divide monomials? How are we dividing monomials? Good question. We know the rule for multiplying monomials. So we take a look at this for a second. And we know that's 3 plus 4 or x to the 7th. So what do we see should be the rule for this? X to the 6 over x to the 3. If we listed them all out and canceled them out, I'd have x3 left over. But we didn't have to do all that, because if we're multiplying, the rule is to add. We could imply that when you divide, the rule is to subtract. So we're going to say this is going to be 6 minus 3. X to the 6 minus 3, giving us x3. Okay? So there is our rule. We're going to subtract the exponents. Okay? And we could write that down. We have x to the m over x to the n, giving us x to the m minus n. Okay? Subtracting our exponents. And we look at another example. I have x12 over x5. What do I get here? We're going to get x to the 7th. 12 minus 5. Very good. Not too bad. It's pretty straightforward. We see that. But then we can get a couple things out of that that are very important. What if I have this? I have x7 over x10. Same thing's going to happen. We get x7 minus 10. Since we're all experts at sign numbers, we know that 7 losing 10 gives me x to the negative 3. Which also tells us that if we cancel the way we did originally, we'd get this. We get 1 over x to the 3. Okay? So the negative exponent actually means a small number, a decimal number, a small number. Negative exponent does not mean a negative number, it means a small number. So if I looked something like this, 8, I would get x to the negative 2, which is the same thing as 1 over x to the 2. Which also would mean